Okay, so today we'll discuss with class 12 physics. Your class 12 physics syllabus, okay, the first 5 chapters, the first 5 units is based on electromagnetism. It means half of your syllabus is just a study of electromagnetism. Is it okay? And the remaining part of your syllabus will be strictly based on modern physics. Modern physics. Very interesting part of physics. Okay, very, very interesting. So many applications, modern physics. And the first part, okay, of your physics syllabus will be electromagnetism. So this is where we are going to start. Alright, we are going to start with the electromagnetism. Electromagnetism can be classified into 2 parts. Electromagnetism can be classified into 2 parts. The first part is electrostatics. Electromagnetism can be classified into 2 parts, electrostatics and electrodynamics. Electro means electrons. Okay. Electron means electrons. Electrons are charged particles. Okay. Statics. Okay. Electro means electrons. Electrons are nothing but they are charged particles. And then statics means at rest. Static means at rest. So electrostatic means charged particles at rest. Okay? The charged particles, they cannot move from one place to another. They cannot flow from one place to another. Okay? They remain confined within the body. So that is electrostatics. Electric charges at rest. Charged particles at rest. And electrodynamics. So, okay, so this electrostatics is going to be the first chapter of our class 12 physics. And electrodynamics. Electro means again the same, electric charge or the charged particles. Dynamics means in motion. So charge in motion. Charge in motion is known as your electrodynamics. So charges in motion, what does it lead to? Charge, if a charge is in motion, it will lead to electric current. Okay, it will lead to electric current. If there is an electric current, there will be a magnetic field. No? So in electrodynamics, we study about charges in motion. Charges in motion, it constitutes electric current. Electric current gives rise to magnetism. And then we'll study, under this we'll study about electromagnetic waves or electromagnetic induction, electromagnetic waves. And then we study about alternating current. So this will cover half of the syllabus of class 12 physics. Is it alright? So the first chapter in class 12 physics is your electrostatics. So here we are going to study the charged particles at rest. Alright? Okay. So that's a small introduction on your syllabus. Okay. Now, you need to write now. Okay, it's not necessary that you write whatever I say. I actually want you to listen very carefully. And when I'm done only, you will start writing them, okay? Now, I think that will be more helpful. If any difficulty, you can ask me again. I can repeat that a multiple number of times, integral number of times. Okay. Okay. So the first topic, so electrostatics, class 12, chapter 1, electrostatics. So today's class, we're just going to have an introduction of this electrostatics, okay? So electrostatics means charges at rest. Now, what is a charge? What is a charge? What is a charge, or what is an electric charge? What do you say about this electric charge?
Is the property of matter.
Okay, it's a property of matter. Okay, correct. But what kind of property is it? Charge is an intrinsic property of matter. We call this electric charge as an intrinsic property of matter. Intrinsic meaning something which cannot be further divided, like fundamental unit. Okay, something which cannot be further divided, something which cannot be further studied, something which cannot be further classified. Are you getting that? Like mass. Mass is also an intrinsic property of matter. Who can create this mass? Who created this mass? Can you create a mass? No, you cannot create a mass. You cannot destroy a mass, okay? Mass also cannot be further classified, okay, into other components. Is it okay? Now, mass ke tangibo na paribo. Now, you cannot further divide a mass. Mass hole taibrabi aru simpler panabo na paribo. Is it okay? So that is, mass is also an intrinsic property of matter. Example, time. Who created this time? No. Time cannot be further researched into other components. Time cannot be further classified into other components. Is it okay? Time broken down kurubo na paribo. It will last hobo. Nah? So that is intrinsic property of matter. So in class 11, you have studied in units and measurement. There are 7 fundamental units, right? Okay, length, time, mass, charge is one of them. Alright? So charge is an intrinsic property of matter. Intrinsic means something which cannot be further studied, something which cannot be further researched. It will last. Okay? That is the meaning of intrinsic property of matter. Look, you cannot see. Yeah, it's difficult. Okay, you can see now? Alright. So that is charge. Okay. This. Okay. Let me tell you some difference between this charge and mass. Tell you something between. See, charge is also an intrinsic property of matter. Mass is also an intrinsic property of matter, right? No? Mass also cannot be further divided. It cannot be further researched. Same with charge. Is it okay? But what is the basic difference between this charge and mass? Mass, can you have -4 kilogram of iron? No, you cannot have -4 kilogram of a substance, right? No, you cannot have a negative kilogram of a substance. What does that lead to? Mass is always positive, but charge can be positive or negative. We have positive charged particles, protons. We have negatively charged particles, electrons. So charge can be positive or charge can be negative. Okay? Mass. See, you have studied in the lower classes, mass does not change, right? Whether you go to space or whether you go to any planet, okay, whether in vacuum or in any medium, mass always remains constant. But mass varies with speed. Mass varies with speed. Just say an object is moving at a very high speed. Then for an object moving with very high speed, its mass will decrease. If an object is moving at a very high speed, its mass will decrease. How? You have not studied this one. We'll study in modern physics. Relativistic mass. M is given by m naught upon square root of 1 minus v squared upon c squared. This is the relativistic formula for relation for mass. ಇದು m0 की को rest mass. Rest mass. Rest mass means mass of an object at rest. Mass of an object at rest. And this m is mass of an object when it is moving. Is it all right? In class 11 you have studied like this. In class 11 you have studied like flow of water, flow of the water, oscillation of the simple pendulum. These are large bodies. These large bodies, as they move, their speed or their velocity is very low. It's very low as compared to the speed of light, right? If v is very, very small as compared to the speed of light, then v can be neglected as compared to c. In that case, v squared by c squared will be 0. It will be 0. Then in that case, this m will become m naught upon square root of 1 only. Square root of 1 is 1. In that case, your mass will be, mass of an object in motion will be equal to its rest mass only. No changes in mass. For an object, okay, for a larger object, it moves at a lower speed, the speed, no? If an object is in motion, a large object is in motion, okay, its speed will be very, very, very less as compared to the speed of light. In that case, there is no difference in the mass. In that case, the mass does not change. But when a small particle, just say elementary particles, no? Just like a proton and electron, okay? When an atom, when this object starts to move, okay, at a very high speed, then in that case, the mass of that object varies. Mass of that object changes. Alright, no? Okay. But for a charge, but for an electric charge, charge does not vary with speed. Vary with speed. Suppose electrons, charged particles, they move at this speed. Okay, they move at this speed. But even though they move at a very high speed, 10 to the power 6 meter per second, they do not change. Okay, no? Charge to kidabi speed lo vary no kore, speed lo change no kore mo. Is it okay? A charge is if a charged particle, even though it is moving at this speed, it will not change. It does not change. So these are some of the basic difference between charge and mass. Are you clear? Mass can be positive. Mass is always positive. Okay, you cannot get a negative mass. But charge, we have positive charge, we have negative charge. Protons are positively charged particles. Electrons are negatively charged particles. Mass varies with speed. Mass of an object changes with speed. Alright, now? But charge of an object or charge do not vary with speed. Charge to kidabi speed lo change no hobo. Is it okay? A charged particle may move at a very high speed, may move at a very low speed, but it does not change. The charge of an object does not change. Alright? Suppose electron naga charge to kimanaze. Okay, suppose electron naga charge to 1.6 into 10 to the power minus 19 coulombs as it. Electron naga charge to. And even though electron is moving at this speed, its charge will always remain constant. No. Charge of an electron is 1.6 into 10 to the power minus 19 Coulomb. Coulomb means unit of charge. No, Coulomb clearly kasi wale. Coulomb is a unit of charge. So the charge of an electron, okay, charge of an electron. Electrons are negatively charged, so I can write here negative. So charge of an electron is minus 1.6 into 10 to the power minus 19 coulombs. But if even though an electron moves at this speed, its charge always remains constant. Are you following me? But mass of an object varies with speed. Are you getting me? And this is the relation. Alright. This is not important for your examination point of view, not important, but these are some of the small things that you need to know. Is it okay? Yes. Okay, now, actually this charge, no? It was discovered by Greeks. It was discovered by Greeks in the early, like, 600 BC. We are not concerned about how they discovered it, why they discovered it. We are not concerned about that. We don't need history here. But just, okay, we need to know that it was discovered, this charge was discovered by the Greeks in the at around 1600 BC, okay? And how did they discover? By rubbing objects. When you rub one object with another object, okay, then some sparks are produced, right? Is it okay? Due to friction. So that is how, okay, by rubbing method, that is how they discovered this charge. But it is not important for us to study the history of how it was discovered, so we will skip that part. Is it okay? But they say that charge is measured in coulombs. Greek ito time de Jesus born time de. They say that I think 600 BC will be the time of King David, Solomon. Is it okay? Yeah. So the Greeks say that the SI unit of charge is Coulomb. Coulomb. So this is the unit for determining the charge of an object. Is it okay? They also say that charge can be positive or charge can be negative. This was their second discovery. Their third discovery, like charges, they will repel each other. Positive, they will repel. Negative, like charges, right? They will repel. So their third discovery is, like charges, they repel each other. But unlike charges or opposite charges, they will attract each other. Is it okay? So this is what they concluded, and we're still on it. Alright, yes, this is true. It was found that it is true. It was discovered later that it was being proved that it is true. So we are still on this. Is it okay? Yeah. So that is a small introduction on what is known as your electric charge. Alright? Yeah. Now, conservation of charge. Conservation of charge. Law of conservation of charge. We have law of conservation of energy. We have law of conservation of mass. Is it okay? Yeah. Suppose law of conservation of energy states that energy cannot be created nor destroyed, but you can transform it from one form to another form. Like mechanical energy to light energy to mechanical energy. Is it okay? Kinetic energy to, again, different types of energy, electric energy to light energy, and so on. So just like that, conservation of charge also says that charge cannot be created nor destroyed. It's an intrinsic property, right? Yeah. But it can only, you cannot transform the charge. Okay, you cannot convert a positive charge into a negative charge. You cannot convert a proton into a negatively charged particle. Okay, but you can transfer it. You can transfer it from one body to another body. That's the law of conservation of charge. Okay, so charge can neither be created. You cannot create the charge nor destroyed. Charge can neither be created nor destroyed, but it can be transferred. It can be transferred from one body to another body. That's law of conservation of charge. Okay, there is one more point that you need to know in conservation of charge. The second important point is, for an isolated system, isolated, in Hindi we say tanhai. In Nagamis I cannot say what is isolated, but just think that you went to space all alone. Is it okay? And then you accidentally landed on Mars. Your spacecraft is now spoiled, so you are left alone in Mars for eternity. Now you are isolated system. Is it okay? So that's isolated. I don't know in Nagamis how I will say isolated, but you understand the meaning of isolated, right? No interactions with other objects. Okay? To sa object bi ahibo na paribo, noile tai bi major bi jabo na paribo. Confined dikta hoy jaise tai. Is it okay? From the outside world, no? Yeah. You are being separated from the outside world, from everything. That's isolated system. So for an isolated system, the total charge means the net charge. The net charge always remains constant. Always remains constant. Now let me explain this with some example. Let me take an example of a radioactive element. Have you ever heard the word thorium? Thorium, a radioactive element. Thorium. What is the atomic number of thorium? 90. 90. Atomic number is 90. Atomic number means the number of protons in an atom, right? The number of protons in an. I don't know how they have counted the number of protons, but it's just 90. Okay. So the atomic number of thorium is 90. It means the number of protons is 90. So the number of positively charged particles is 90. In this thorium, what I'm going to do is, I'm going to extract 2 charge from thorium. Okay, thorium, atomic number is 90, means the number of protons is 90, so it has 90 positively charged particles. Okay. Now I'm going to extract 2 charged particles from thorium. That means I'm extracting alpha particle from thorium. Alpha particle means a particle having 2 charges, 2 positive charges. Alright? Alpha particle olai dishe. Alpha particle means helium nucleus. Okay? Helium naga atomic number do to ase do. Tami to olai dishe, alpha particle olai dishe. Then we will get a resultant nucleus, right? We'll get a resultant atom. So alpha particle means 2টা charge আছে তো তাই 2টা positive charge আছে তো না তো ಇದು remaining element তো কিমান positively charged থাকিব তাই কিমান positive charge থাকিব তাই তো এতিয়া তো how many positive charge will this element have now? Kile 88. How do you know it's 88? Because yes, their sum should be equivalent to 90. Na tumi to thorium do thangi dishi do holibe taijon milai kena tai laga charge to pai ase do na. That means the net charge always remains constant. Are you getting me? Na the net charge always remains constant. Na harabo charge to takibo. So that when you combine these two, it will be equivalent to this. Na it will be charged to altogether 90, it will be 90. So for an isolated system, the net charge always remains constant. I'll give you one better example. Suppose you have a system, a closed system, okay, which is non-conducting. means bahar bara charge ahibo naparibo. Aru tumi khan yeti laga charge, yeti thaka charge pe bahar jabo naparibo. So just consider that this box is an isolated system having insulating walls, having non-conducting walls. Is it okay? Now I have three bodies. I have three bodies present in this system. This body has a charge of 3 coulombs. This body has a charge of 2 coulombs. And this body has a charge of -1 coulomb. Okay? I take this box and I shake it. Okay? For some time. And I place it again. Then, due to collision, these bodies will interact with each other, right? These bodies will interact with each other, okay? Due to shaking, these bodies will collide with each other. During collision, some charges will be transferred from this body to the other bodies. Is it okay? No? Some charges from this body will be transferred to the other bodies. Again, some charges from this body will also be transferred to the other bodies. Now? No? Some charges will be transferred from one body to another body. Is it okay? Now, later on, it was found that this body has a charge of 3 coulomb. This body also has a charge of 3 coulomb. And you want to find out the charge of this body. Is it okay? Na? Ito laga third body laga charge to be sari bole mo na se na. What is the total charge here? What is the total charge initially? 3 coulomb plus 2 coulomb minus 1 coulomb. 3 plus 2, 5. 5 minus 1. So the net charge of this system is 4 coulomb. Now, for this system, the net charge will be 3 coulomb plus 3 coulomb plus unknown charge, right? But see, for an isolated system, the net charge always remains constant though. So what will be the net charge of this system? 4 coulomb. Is it okay? Initially, tayo laga 4 coulomb tagi shido. Shek kurige na rakhilebe tayo laga total charge to kiman hobo? 4 coulomb ni hobo. Because the net charge always remains constant. Are you getting me? But for an isolated system. So the sum of this algebraic sum of these 3 charges should give you 4 coulomb. Is it alright? In that case, 3 plus 3, 6 coulomb plus x unknown charge, 4 coulomb. So x is equal to 4 coulomb minus 6 coulomb. So x is equal to minus 2 coulomb. So tayo minus 2 coulomb. Tayo all together, kiman coulombs tagi siya? 4 coulomb. Tayo 3 plus 3, 6, 6 minus 2, 4 coulomb. So for an isolated system, the net charge always remains constant. Are you getting me? Yes. This is known as law of conservation of charge. Any confusion? So, the law of conservation of charge says that charge can neither be created nor destroyed, but it can only be transferred from one body to another. Later on, we will discuss how transfer of charge can take place, okay? Yes. And the second thing is, for an isolated system, the net charge always remains constant. So this is one of the examples. All right. Oh, I have forgotten the Greeks, okay? They also say that they give a symbol, a particular symbol for denoting the charge of any object. Charge is denoted by capital Q. In some books, you will find it small q for denoting charge. It's alright, no matter whether you use a positive q or q cannot be positive. Whether you use a capital Q or small q, okay? Q means it represents electric charge of an object, alright? Now the next one is quantization of charge. Quantization of charge. Quantization meaning, I think these things are not given in the video. Okay, I'm just teaching you some extra things that you need to know. Quantization. What is the meaning of quantization? Something which is present. Something which is present in fixed amount. Something which is present in fixed amount. So quantization of charge means, okay, you can take a fixed amount of charge or you can give a fixed amount of charge. It is quantization of charge, okay. See, I'll give you an example. If I say, suppose you went to town to buy some pens. You cannot just ask the number of pens in the form of integers. Sabi na, tumikan pen kini boleh jadi town de. Then you cannot say like, give me -4 number of pens. You cannot say that. Give me 4.7 number of pens. You cannot say that, right? It means buying pens has to be set in fixed amount. Huh? In terms of natural multiple, you can ask pen in terms of natural multiple. Give me 10 pens. Give me 5 pens. Give me 4 pens. Give me 1 pen. Is it okay? Just like that, charge can also be taken in fixed amount or it can be given in fixed amount. Is it okay? Yeah. But see, when you are taking an example of buying sugar, you can buy. It's not necessary that you buy only a natural multiple of kilogram, right? You can buy 4.250 kilogram of sugar. Huh? You can buy 1.125 kilogram of sugar. Is it okay? Again, taking food is also not present in quantization. You can take only 1 gram of food. 1 gram of food means 0.00 or 0.01 kilogram. Is it okay? No? I think 0.001 kilogram. Huh? Suppose your parents prepared a very healthy meal. Okay, you are not in a mood to take. They put 2 kilogram of rice and along with dal, meat, okay, mixed vegetables. But since you are not in a mood to take, you just take 1 particle of rice and your dinner is done. It means you are taking only 0.0001 gram of food. So taking food or buying food stuff is not present in quantization. But when it comes to charge, okay, it exists in quantization. So you can only give a fixed amount of charge or you can take a fixed amount of charge. Alright? Yeah. See, there are smaller particles. See, we consider that protons. Okay, let me take example of electrons as well. Electrons. They are the smallest particle of a matter. We think that, okay. But there are smaller particles as compared. There are smaller particles than protons and electrons. That you will study in the higher classes, okay, when you study physics. So there are more, we call them as elementary particles also. We can call them as elementary particles, positron or neutrino, antineutrino. Those elements, those particles are also there. So there are some other particles which are quite smaller than protons and electrons. Is it okay? Now, charge of an electron only in magnitude 1.6 into 10 to the power minus 19 Coulomb. That is the smallest charge. Charge of 1 electron is the smallest charge that exists independently. See, there are smaller particles than the electrons. Those particles also they have charge. Okay, lesser than this one. The size of those particles are less than electrons, so they will have charge lesser than the electrons. But they do not exist independently. Are you getting me? So the smallest charge that exists independently is E, charge of an electron, which is equal to 1.6 into 10 to the power minus 19 Coulomb. So when you measure the charge of an object, the charge of any body, then it has to be an integer multiple of E, quantization of charge. Are you getting me? Are you getting that? That is quantization of charge. What is the charge of this body? What is the charge of this body? Okay, 24E. Suppose it is all negative charges. What is the charge of this body? Minus 24E. Is it okay? So charge of an object can always be measured in terms of integral multiple of E. Integral means I'm saying integer multiple of E. And you know that integers means and so on, minus 5, starting from minus infinity, minus 5, minus 4, minus 3, minus 2, minus 1, no charge, 1, 2, 3, 4, and so on up to positive infinity. So charge can always be present. Charge of an object is always present in integer multiple of E. And that is known as your quantization of charge. Alright? So the total charge of your body is always present in integral multiple of E, where n is any integer. If a body has overall positive charge, plus any. If a body has overall negative charge, minus any. This is known as quantization of charge. Are you following that? So the only thing that you need to remember here is charge of one electron, charge of an electron is the smallest charge that exists independently. There are some more particles smaller than them. They have also charge, but they do not exist independently. So we take the charge of an electron to be the smallest charge. So the charge of any body should be present in multiple of E. Not rational multiple of E, not real multiple of E, but integer multiple of E only. Is it okay? Alright. Now, let us discuss the methods of charging an object. Okay, there are 3 methods of charging an object. I don't know 3 or 4, but I will know now. Methods of charging. Methods, yeah, 3 only. Methods of charging. The first one is charging by conduction. Charging by conduction. So what is charging by conduction? Let's see. Suppose you have a body fully charged. Let's say that it has excess of positive charge. This is a positively charged body. Okay, you have a positively charged body. Oh, you can take a negatively charged body, no problem. Okay, so suppose this body A is positively charged. Now you take another body B having no charge, means having 0 charge. Is it okay? Conduction means you are going to charge this body by placing in contact with this charged body. You are going to charge this uncharged body. This is an uncharged body, so you want to charge this body. So in order to charge this body, you have to place this body B in contact with this A, which is fully charged. Is it okay? Now, as you place this body B in contact with A, the positive charges from A will start flowing towards B. Is it okay? Positive charges from A will start flowing towards B. It will keep on flowing. The positive charges will keep on flowing till the charges in the two bodies becomes equal. That is how charging of an object can be done by conduction. Are you getting that? Yes. The next one is, second one, charging by induction. Charging by induction. So there is a body here. Let's say that this body has excess of negative charge. It's a negatively charged body. Alright? It's A now. You have another body having no charge. So this is your body. Now I want to charge this body by the method of induction. So what I'm going to do is, I'm going to place this body not in contact with A, but very, very, very close to A. Alright? I'm going to keep this body, uncharged body B, very close to this charged body, such that the distance between the two bodies should be very less as compared to their thickness. Itula distance to itula thickness very close to each other. Okay? Now what happens? This is a body. Every body is made up of every body is made up of atoms. So there are a large number of atoms present here. Is it okay? Now, due to the negative charges present in this body A, no? The atoms that is present in this body B will be stretched. By negative charges asado. 특히 그리고 itu body brana, itu body laga atoms to. Sabi de kiyo. This is an atom. Atom has positive charge at the center. The negative charges around, right? Na? Neutral asado do na. 특히 그리고 what happens is, since this body is negatively charged and is placed very close to B, what happens? This negatively charged will start to attract the nucleus, okay, of the atoms present here. Nucleus to positively charged acido. Kile kuletai protons acido pitordi. Now, 특히 그리고 the nucleus, what will happen? Will be attracted towards the negative charge. See, it cannot get transferred because they are not in contact. Will be nucleus to atom to ki hobo? Atom to stretch koribuni. Atom to inega stretch koribuni. To nucleus to ikta site di ahibo. Electrons to ikta site di jabo. Electrons to taiba repeal koresi no. To electrons to ikta site di jabo. Nucleus to ikta site di jabo ni. That means every atom present in this body B will become polarized. It get polarized way. Polarized way. Is it okay? Atom stretchable nucleus will come, is attracted by this negative charge. They will come towards one end, that is towards the negative charge, and the electrons will go towards the other end. So the atoms that is present in this plate B or body B will become polarized. Be neutrally acidotai. Because the number of positive charges is equal to the negative charges, to tie to neutrally acidity. No. You bring another body having no charge. This time you place in contact. See, let's say another uncharged body C having no charge, placed in contact with B. The electrons of this body B is being repelled by this, right? The electrons will start flowing towards this body C. As a result, body C will become negatively charged. And this body B will become positively charged. So you get two types of charges here by the method of induction. Alright? There is one more example I can say. Suppose this body A, it's negatively charged body, full of negative charge. I want to charge by induction, okay? So I'm going to place an uncharged body having no charge. This body has no charge. Placed very close to A. Then what will happen? Due to these negative charges in A, the atoms that is present in this body B will become polarized, right? Nucleus to ikta site aibo, electron cloud to ikta site fale jai jabo na. No, now, earthing DB. You connect this plate B, body B to Earth. What is Earth? Earth is ocean of electrons. Earth is ocean of electrons. Are you getting that? To earthing dile ki hobo? Since Earth is our ocean of electrons, electrons will start flowing towards this plate B. Is it okay? Electrons will start flowing towards this plate B. As a result, due to the excess amount of electrons present over this body will become negatively charged. Are you following me? So this is how charging an object can be done by induction. Are you getting that? Yes. The third one is very simple. That is how the Greek discovered charging by friction. Charging by friction. You have done this by yourself also when you were kids. Rubbing a scale with your hair, then the scale will start to attract some pieces of paper, right? Because it has become a charged body. A scale and your hair are neutral. Is it okay? But as you rub the scale on your hair, what happens? The outermost electrons the outermost electrons are called valence electrons, right? Every atom has a valence shell, outermost shell. The electrons present in the outermost shell are called valence electrons. So as in some bodies, the valence electrons are loosely held. Okay, so when you rub one object with another, the valence electrons, the electrons in the outermost shell which are loosely held, they will jump to another body. Is it okay? So when you rub a scale on your hair, okay, just say that your hair, the electrons in the outermost shell of your hair are loosely held. So they will be transferred to the scale. Is it okay? As a result, your hair has lost some electrons, so your hair will become positively charged. Whereas the scale has gained excess electrons, it will become negatively charged. As the scale has become a charged particle, it will start to attract some small pieces of objects. Are you getting me? That is how charging can be done by friction. So that's the introduction of these charges. Is it okay? Yes. Now we will study about the Coulomb's law, which is very, very important for the examination point of view. Okay. Coulomb. So whatever we have discussed till now, before we start this Coulomb's law, whatever we have discussed, you can just highlight on your books by yourself, and we can start with this Coulomb's law. Okay. Yeah.